Welcome back. We are going to continue our discussion of points on a circle using sine and cosine. Sine and cosine are the first of our trigonometric functions that we're going to encounter in this class. And I'm going to walk you through developing those. So let's think about a circle. Okay. And suppose I've rotated some angle theta. And that got me to this point, x, y, on my circle. My circle has radius r. There is a relationship between that angle and those coordinates, and that's what we're going to develop in this video. So what I'm going to do is I'm going to drop a vertical straight down from that point to the x-axis. And understand that we can do this no matter what quadrant we're in. So if we are over here in the second quadrant, we would be at a different point, right? And have a different angle, but we could still drop that vertical and we would have a different angle theta. But this will work no matter what quadrant we're in. And we call these angles that touch the x-axis reference angles. So these are what we call reference angles. And we'll come back to that terminology. I just want to point out to you that that's what we're doing here. So I'm going to erase this guy over here now so as to not confuse us. Whoops, that wasn't what I wanted to erase. Okay. Now I've got one circle on here. Let's suppose I have got a smaller circle. I could do the same thing with a smaller circle, right? All right. Let's move my center point towards actually a center point. Okay, close enough. And so this is a different radius and a different point, but the same angle. So pretend that these are the same angles. Okay, so theta is equal to theta. Here's the deal. If I repeat this exercise of dropping that vertical, so that vertical has got a length y2, right? And this guy's got a length y1, because this is going to be y1 and x1. And it turns out, I'm going to show you this in Desmos here in a second, that the ratios between y1 and r1 are equal regardless of the size of our circles. In fact, you can see that, right? If I were to center that small circle inside, we've got similar triangles. And so the ratio that involves the x's is similarly equal. Okay, now we want to give these ratios names because they turn out to be really important. And you may remember from earlier classes you've taken that included right triangle geometry that if we've got a right triangle and if we mark an angle here, there were relationships between, we gave names to the relationships, the ratios of the different sides. And in fact, what we did was we said that the sine of my angle theta is equal to the length of the side opposite that angle divided by the length of the hypotenuse, which in terms of my triangle within my circle is my y divided by my radius. And that the cosine of my angle theta is the length of the side adjacent to the angle divided by the hypotenuse, which in this case would be x over r. These are our relationships between our angles and our coordinates. So think about, for example, the point 34 is on a circle of radius 5 at some angle theta. Now we are not in a position yet to find theta. That comes later in the class, but what we can do is we can find sine theta and cosine theta. So if we sketch our circle, and we sketch our point 34. 1, 2, 3, 4. Okay, let's see. I can do this. One, 2, 3, 4, almost. 1, 2, 3, 4, 5. Okay, there we go. So I just adjusted it so my grid is 1. And I've got a circle of about radius 5. 1, 2, 3. So this is my point 34. On my circle, this is my angle theta. Think about my right triangle. And remember that sine is, so the sine of theta is y over r. Cosine of theta is x over r. So that means that sine theta is 4/5. Cosine theta is 3/5. Okay, so goody for us, right? And what this means is that we can find the coordinates of any point on a circle. The coordinates of any point on a circle of radius r are given by x equals r cosine theta, y equals r sine theta, where theta is the angle of rotation that gets us to that point. And we're going to think about this in terms of standard. So this is a circle centered on the origin. And we're going to start our rotation from the positive x-axis, so from standard position. So in other words, suppose I am on this circle and I'm over here in the second quadrant. This is my angle theta. I can still get to the coordinates. R cosine theta is my x coordinate and r sine theta is my y coordinate. All right, we're going to come back in a minute and talk about an identity, a relationship between sine and cosine, and we'll do some problems.